So good afternoon all. So once again, I am glad to invite you all for this 19th evening talk conducted by HSE Forum in association with National Safety Council Kerala chapter. I would like to invite Mr. Gokul, Manager HLL for welcome address.
Thank you. Good evening all. I welcome NSC-Kerala chapter, HSE Forum, and our esteemed speaker, Mr. Sri Prakash Karnamurthy, Zonal Manager South India, Shimmers India Private Limited, and our great listeners. This is our 19th monthly evening talk, and today we will discuss about the topic modern trends in machine guarding and safety sensors. A small quick briefing about our today's speaker, Sri Prakash Karnamurthy. He is electronics and instrumentation graduate with 15 years total experience in industrial automation, in which 10 years experience in functional safety field. He is leading South team of Shimmers India Private Limited, which provides complete solution for machine safety requirements. He is also product manager for modular machine guards called Safety Fence, and he has executed many safety implementation projects in existing machines of different industry verticals. I now hand over the forum to our esteemed speaker to continue the session. Thank you.
Hello, good evening, sir. Thank you once again for thank you once on all for giving this opportunity to share some ideas or information about machine safety concepts. So I hope my screen and my voice is audible and clearly visible.
Yes.
Yeah, if any interruption, please stop me.
I'm Nanda Kumar. Welcome to all. Can we start the program? Mr. Vinod?
Yes, sir. We can start the program. So if there is any queries or comments, can be raised in the comment box, sir. So at the end of the session, Mr. Prakash will answer all the comments and questions raised. So we can hand over the session to Mr. Prakash.
Thank you, sir. I once again repeat. Hello.
Nandaguma, sir. Hello.
Prakash, sir, please continue, sir. You can start the session. Thank you.
Yeah. If my voice audio is anything disrupted, please stop me. If screen is interrupted, please let me know. Okay. Yeah, I'm just going towards the topic. So regarding this safety, safety is a. I request please mute the mic because I'm getting the echo. Yeah, thank you.
Okay, sir. Thank you.
Yeah. Regarding the safety, every industry or every machines or any type of industry, we need a safety. Okay. But there is a reference point or there is a benchmark point, which level of safety or what level of safety to be maintained in the respective industries, respective machineries. For each and every machineries and each and every process application, there is a reference books or reference standards are available. So there is a lot of standards available in the global market. So one is IEC, ISO standards for the international markets, which is carried out throughout the globe. If you see only in Europe will be EN, ISO, IEC standards. If you see in Asia, especially in India, BIS, Bureau of Indian Standards, or ISO standards. If you see in US, it's a OSHA standards. So we will all the standards are saying the same concept with respect to each machineries, but we will see with respect to the European norms and as well as how the BIS has been adapting some of the standards from the European norms. As I said, EN ISE or EN ISO standards, it's a European norm which is also carried out throughout the global industry segment. And recently, Bureau of Indian Standards in India they have adopted some 32 standards, important standards from this ISO standards, EN ISO standards. So before going to the number, which are those standards, let's see what are the most important standards which has to be carried out or followed by all the factories, like factory managers or production heads or safety officers, safety inspectors, has to get into this particular standard requirement. This is a very vast topic, but I'm trying to cut short and ensure that I will cover almost all the basic points. So based on the further questions or some other topics or things, we can go clarify maybe this session or some other sessions. Before going into the standards, I will just explain how the optimization of the safety can be done. Okay, there is two concepts. One is if you're designing the machines, okay, you can do this concept from the design stage. If the machine is already built, which is running in a factory, then how we have to proceed with respect to the safety optimizations. Let's consider this is your machine, and it's a small graphical example I'm saying. So this machine doesn't have any safety implementation or doesn't have any safety guards or something. So before we have to go for the safety consultant, a proper safety consultant has to review on this existing machine. Means he has to do some risk assessments, he has to do auditing on this machine, he has to talk to the production, he has to talk to maintenance, he has to talk to the production laborers, okay, and he has to talk to the design team, whoever involved in this particular machines. After that, he has to do the consulting activity. What if suppose something happened in this machines while operating? What is the effect of this? So this kind of activity has to be done by the consulting team, that is called risk assessments. And then he has to do some engineering activity to see how it can be, first of all, documentation, and then how it can be go to the next level so that risk can be reduced. And then you have to implement. So whatever the solutions which have been identified, okay, this has to be implemented on this particular machines. And then again do the documentation activity before and after. And then we have to train to the people who are working in the machine again, because before the operating of the machine would be different, and after implementing of safety, this would be entirely different. And then last is the validations. Again, the consulting team will come back to this cycle to check whether whatever we have done initial phase, risk assessment or consulting, whether that has been clearly or completely has been implemented. So these two part will be taken care by the consulting team, and this would be of engineering team. So safety implementation, it's not a one-man person who can do all this activity. It is a teamwork. So everyone has to put their contribution in this. So after doing this, I'm just giving an example. This would be like such a way that all the pinch points, all the things have been covered properly without affecting the productions. And production team also can be able to work on this machine smoothly without any issues or with respect to accident or something. So this is the basic optimization cycle. So in general, it will be like this, but the consultant has to go through each and every machines. Means machine will be not same. Each and every machine will be different. So consultant should have the idea which kind of reference document has to be, or which kind of standards to be followed for which kind of machines. So that is most important. So the standards, harmonized standards. These standards have been classified into three types: type A, type B, and type C. Type A is a basic safety standards, that is for risk assessment standard. That is, we can call it as one of the example of this is EN ISO 12100. Okay, this will be a generic standard. So this can be used for any kind of missions, because it can go up to the process. I mean, one by one process it can go. You can use this standard, verify and check whether it is as per the safety. Okay, but if you are using the press machine, or if you are using some tire building machines, if you are using some conveyors, if you are using some robots, something related to this particular thing, there is also type C standards where it will directly tell you the for which mission which standard has to be used. If you are using press mission, you want to implement some safety, you directly go to the press mission standards. This will be incorporate of all these A and B together. So you need not to go again to generic standard, go to for one function. So because for example, I'll say in any kind of mission, any kind of missions, you'll be having some emergency stop. So to validate whether this emergency stop has been properly installed, properly wired and properly taken as output, everything. If you go into that standards, if you want to go likewise safety like current. So one by one, you have to go with respect to type A standards. But if you directly go to the type C standards, these standards will also have some incorporation of these two standards. It depends. It need not to be entirely same what I'm saying, but you can directly refer to the standards with respect to the mission classification. Press, you can go to press standards. If you are using extruder missions, then you can directly go to the extruding mission standards. If you are using the packaging missions, so that you can directly go to the packaging mission standards. Okay. And B standards is further classified into B1 and B2. Okay. B1 is with respect to safety aspects. Okay. How the control system has to be there. What is the safety distance should be maintained? What is the safety distance should be maintained when you are using some safety components like light curtains or scanners, safety mats? What is that if you are using press, you are working on press machine, how this 2-1 control station has to be placed from the hazard area. So all this is with respect to safety aspect. Type B2 is with respect to safety of the products, safety products. Suppose if you're using emergency stop in your machine, how this machine should be, this emergency stop should be designed, whether you are whatever the emergency stop which are used in the machine, which is complying to the safety standard or not, you have to verify. It need not to be that you use general push button for using the emergency conditions. So whether you're really using the emergency push button for this application, you have to verify with reference to this document B2. We will see in detail with some example. As I said, type A, that is for risk assessment standards. That is 12100. Okay. If B is divided into B1 and B2, and B1 is with respect to safety aspect, that is EN ISO 13849-1 SRPCS. SRPCS means safety related parts of the control systems. If your machine is having the control systems, the entire safety related parts of this control systems will be implemented based on this particular standards. And then safety distance calculations and validations. As I said, when you define the safety level which is required after doing the consulting activity, and after your implementations, you have to do the validation. Even for that validation also, you have to follow certain standards. That is called 13849-2. With respect to B2 is like emergency stop 13850. Interlocking devices. If you are using some interlocking devices in your machines, then it's 14119. If you are using mechanical guards, forget about electronic components. If I'm using a mechanical guards, even that mechanical guards has to be comply with the standards 14120. Okay. As I said, for type C, it is with respect to missions. Directly, you can go to this particular standards and you can fetch requirements and you can do the implementations like woodworking machines, hydraulic presses, extruders, conveyor system, packing machines, rubber and plastic machines, mechanical press, handling equipment, industrial robots. So you will be having different variety of machines in your factory. So you can directly go to this particular C standards and you can refer it. I'm just coming back to again A standards, that is EN ISO 12100. So this is the standards which used by the consultants for doing the risk assessment in the mission. Okay. So you can see here the consulting risk assessment EN ISO 12100:2010 or IS 168819.:2018. This is the nothing but a Bureau of Indian Standard. So this is refers to the our Indian standards, which is nothing but adapting the same particular standards of consulting activity. Okay. By any chance, you can explain me or you can give me the difference between the risk and hazard. Okay, I'm just carrying out. Yeah, please, sir. Someone has. Hello. Okay, I'm just carrying out again for next topic. Means hazard. Hazard is a thing which is available in any kind of machines or any kind of process. Without hazard, there is no any manufacturing facility will be there. So all the manufacturing facilities and all the machines will be having the hazard. Different kind of hazards are there. Electrical hazards, mechanical hazard, ergonomic hazard, chemical hazard, temperature hazard, heat hazards. Many hazards are there for different variety of machines. Okay, this is available in all processing or all manufacturing industries. Okay, without hazard, there will be no machines or no process. But risk is something where how frequent or how much you operator are exposed to that hazard, how frequent or how easily they are exposed to that hazard. Exposing to the hazard is a thing is called risk. Okay, so driving a bike in a road is a hazard, but how you are exposed to the accident is the risk. So that is a simple example I'm saying. So if you see, this is the risk assessment process. Okay. First and foremost, if you go through the mission, you have to see what is the limits of the mission. What can it cannot perform, what it cannot do. All these limits of the mission has to be identified. And then you have to find out the hazards with respect to the missions, whether it is a furnace. So temperature is one of the hazard. Whether it is a press machine, then there is a chances of operator getting punched between the pressing operations. Whether if it is something high voltage testing area where there is electrical hazard is there. So there are variety of hazards. There might be multiple hazards in single mission. It may not be that only one hazard will be there in one mission. There will be multiple things will be available in that hazards. And then risk estimations. So the risk will be there, but what is the level of risk? Whether it will be affecting us very badly or it may not affecting us badly or something. You have to risk estimation and evaluate this risk. So all these things you have to complete and you have to provide a solution to reduce the risk. If this risk can be reduced, okay, then that could be the end point. If you find no, then you have to again risk reduction process has to be implemented by some external factors, using some external factors like guards, our interlocking devices, or if you find something else, design changes or something. So if you find after implementing this, again you have to do the risk assessment from the starting, and you have to identify whether the limits are changing. Okay, whether the hazards, because by implementing the new process, whether any new hazards has been created, that has to be again once again verified. If something is created new hazard, then you have to do all this process. For example, you are implementing the mechanical guards over the machines. Okay, so you are trying to reduce the risk. Okay, you are implementing a mechanical guards, but when you do the again a reassessment to check whether with this solution whether any other hazards are formed, there might be the chances that these mechanical guards are not properly placed and it's too heavy and it can fall on the operator who is standing near to the machines. So that is also one of the mechanical hazards. So this is also one of the point which you need to re-verify after implementation of any safety solutions. So this process has to be continued, and after everything is clear, you can come to the end. Okay, this has been adequately, the risk has been reduced. It cannot be like 100% you have removed all the hazards, but you have to remove the certain hazards so that the risk level will be very, very minimum, very minimum. As I said, these are some of the hazards in any of the missions. So you have to identify the hazard, you have to give the hazard rating number, and then you have to check relevant safety standard to mitigate the risk. And you have to identify what is a performance level required, means what is the safety level required for this mission. Let's say you are going to do the assessment in the press mission, and you find out there are a lot of risk in this mission because of the different hazards are there. I mean, hazards are there, and the operator is also exposed to those hazards, and the risk level is also very high. Means if anything accident happens, it can go up to the fatality. Then you have to define that you need highest level of safety to be implemented in these missions. For that, you have a separate process as well to identify the performance level. This is called safety level. That is safety performance level required. So after this, you have to do the implementation activity, and you have to do the validation whether required performance level has been implemented. So this is the validation process. So we will see upcoming slides what are those procedure to identify this performance level. So for minimizing the risk, there are 3 steps. Risk reduction. For example, let's say this is the one of the risk. There is a one press is there. So where you have a chance that your operator finger can be crushed. Okay, with this particular process. Okay. So you find this is the crushing point is one of the risk in your mission. First is direct safety implementing, means if your mission is in design stage and if you want to do some changes in the design itself, means you are changing this pressing options. Okay, this process, this particular operations in a such a way, the design has been changed in a such a way so that even if you insert the finger, this will not damage your finger. This process will not damage your finger. Okay. So this is called direct safety. Such a way, if you want to design a mission, you have to do the risk assessment during the design stage itself. And if you find that is a chances of any accidents can happen in this mission during the design stage, then you have to think of doing some changes in the design itself so that you can avoid such kind of hazards during operations. But if there is a limitations, you cannot do this implementation because of certain limitations in the missions. So you want to do some, you cannot do this activity. Then you have to do the indirect safety. Means where people like us can put into our ideas, and we can try to put some implementations by providing external guards, and so that your fingers will not reach that particular press area, all these things. But your process requirement, you find that you cannot put any of the mechanical guards like this. Your process requirement, because a loading point, you have to load the component. You cannot avoid this particular operations. You have to insert your fingers. Means then there is no other options. Like there is a temperature. The temperature requirement to be high as per the process requirement, but you cannot avoid the temperature should be low because then your process will not completed. So you have to certain process you cannot do any changes. So you have to put some stickers like signage on these machines. Okay, this is the crushing point. This is a high temperature surface area. Likewise, so this is called indicative safety. But here last options, if you tried direct, indirect, and then you can come to this indicative safety. Till the time you have to do some engineering activities, we have to do some thinking related to design or indirect concepts, and then finally you can come to the conclusion with respect to the user of the machine and designer and as well as the consultant. So this is direct safety is to avoid the hazards, indirect safety to protect the hazards, okay, and indicating the hazards. So these are the three things which has to be carried out during the risk reduction process. Risk mitigation means you have to this is the place where people like us can put our products as well as our ideas to do the some key measures for risk mitigations. So whenever you find the hazards and the risk level and everything, so there is an option, any mission, there is an option putting as guarding, means separate guarding and non-separating guarding. Separating guarding means fixed door. You put a door or fixed fence throughout the machine so that no operator can enter and do this activity. And so that whenever there is any requirement to access the machine, he has to switch off the machine or you have to power off the machine, get inside, complete the maintenance activity, come out, and then he can start the machine. So for that, it's a fixed fence. So completely fixed will be there. There is no point of removing it. But if you want regular access of the machines every what do you say, every shift or every 1 hour or something, and then you have to put a door, okay, and the door has to be properly interlocked with the control systems. Means if the door has been opened, that the most important critical components of the machine will not run, okay, or it will run in very slow speed or something. And it is has to be in if suppose guarding is also there, so means you cannot open the door just like that. You have to give the electrical signal to the device which is mounted on the door, telling that, okay, I want to open the door, can you allow me? So that is electrical signal will be going there. The moment the electrical signal is received, it will allow you to unlock the device and then you can open the door. Here it is just interlock, means whenever you open the door, you can open the door at any point of time. But if you open the door, immediately machine will go to the stop mode or it is slow speed mode based on the requirement. But interlock with guard locking is something, the device will be mounted on the door, okay, and the door will not allow you to open the at any moment. You have to get a permission from the control system. Means you have to either type some password and enter that in the HMI so that it will give the pulse 24 volt DC to this device, and then you can open, you will be allowed to open the door, unlock and then open the door. Okay, but the moment you get this signal, this device will stop the entire process in the machines. So this is the one with respect to movable part of the door. In non-separating guarding, suppose you cannot put any guards surrounded by these machines because of your operating time, means production time, downtime would be there. Suppose opening the door, feeding the component, again closing the door and then start the cycle will increase your production time. So you want to have it, keep it open, and you have at the same time you need to have certain control measures for safety. So there are certain components which has to be used along with this machines. That is a non-separating guarding things. One is emergency stop. One is second thing is sensitive protection. That is safety like curtain or safety scanners or something, and safety mat. These are the product safety bumper, safety edges. All these things are used during the non-separating guarding. And then to and control stations, and then enabling devices. So means you have to work along with the machine by using these two devices only. So without this, you cannot able to operate you cannot start the cycle. Such a way it will be engaged with the machines. So there are some of the examples with respect to safety standards. As I said, the risk assessment, that consultant would use the standards 12100 for any risk assessment activity. If you are using emergency stop, you have to verify this emergency stop is with respect to EN ISO 13850. If you are using a mechanical safety fence throughout the machine, through robo or some other machine, whatever might the machine, then you have to comply to the mechanical standards EN ISO 14120. If you are using the interlocking devices in the door of this guard, suppose, as I said earlier, if you want to open the door, you have to get the signal. So such kind of interlocking devices you are using in the door, you have to follow the interlocking devices with the which complies to the 14119. if you're using a safety mat, and this is the standards 13856-1. If you're using 2-1 control station, it's EN ISO 13851. Safety distance is EN ISO 13855. And this is the SRPCS, that is of I said now 13849, which can be used for calculating the performance level required. So I'll just come to any clarifications or something. If any questions, you can put it in the chat box. But till now, the topics which I've covered, if you find anything to be discussed again, you can let me know now.
So it's okay, sir. Yeah.
Okay, thank you. Sorry. Next is many manufacturing facilities are using some of the safety components in their machineries to protect the operators, but still there are accidents are happening because of one is the components which are used for safety is not as per the standard requirement, or if that is also as per standard, but still it is not used as per the safety distance or something like that, means it is not used appropriately as it has to be used. One is, one of the example I'm just trying to give you in a pictorial format. One is safety light curtain. This would be the product which can be used for press machines or any SPMs or whatever, wherever the operators keep on engaging to the machines. So there are some chances the mounting would be like such a way. They will be fixing this light curtain a little bit away from the machine, and there will be a gap. So operator will cross this light curtain and stand in between this light curtain and machine, and they can do this activity. And height is not appropriately selected. Means it is as per requirement, it might not be selected. It has to be selected exactly to cover the entire hazardous point of the machine. So you can see here, this is a proper height selections. And also if there is a requirement that operator has to, this light curtain has to be placed away, then this area also need to be covered either with light curtain or some other mechanical guarding kind of arrangement, so that you cannot able to stand in these locations. Next point is, before implementing any safety light curtains or safety mats or something, you need to identify whether you have to identify the stop time of your machines. Then only you can use the light curtain at appropriate distance. Okay, what is the stop time measurements? Okay, means it is an estimation of time where the moving parts of the machine, the complete moving parts of the machine, will come to an end after giving the stop command. Okay, suppose you are pressing an emergency stop in the machine. Emergency stop means the machine has to come to halt situation, halt conditions. Okay, so the time taken from the pressing the emergency stop to the final component of the machine which comes to halt conditions, this is the called stop time. Okay, this has to be measured. Accordingly, you have to select the, or accordingly you have to place the light curtain from your machines. Okay, because let's assume you are using some more safety components. Each safety components is having its own response time. Further to that, this safety components will be connected to the control systems that will be having certain response time. Further, this will be giving the stop command to the machine parts, output devices. It has its own response time, and then mechanically it has to come to an halt. So this cumulative of all this response time, which may be higher. So before that, the accident can happen. So before the machine comes to halt condition, this accident can be happen. So to avoid this accidents, you have to first measure the stop time of your machine, and then you have to implement certain safety concepts or safety distance or something which have to be calculated, and then you have to install your light curtains or safety mats. So this is the one which has to be carried out, which is generally missing at many industries. So you can find, so if suppose operator is trying to put his hands into the pressing area here. Okay, this is the crushing point. So he is trying to put his hand in this particular area. The approach speed, in general, a human being will be having certain approach speed. So that is certain 2 meters per second. So this approach speed can reach, will lead to the accident if this light curtain is placed exactly here. Means the response time of this light curtain and then control system and the machine, before it is reacting, this hand will come into this crushing area and it can able to create an accident. So with this stop time measurement, you have to calculate the safety distance, means not from the machine surface. I'm saying hazard point. This is the hazard point, not this is the hazard point. This is the machine outer surface. You can see here. But this is not a hazard point. Hazard point is a crushing point is here. From this, the distance of the has to be in the lichen has to be placed as per the safety distance arrived. So this should be taken care even if you are using a proper, whatever the brand or whatever the high response time of the light curtains or whatever might be, but still each device is having its own response time, and this response time can cumulatively create certain gap. So that has to be fulfilled with doing the calculating the safety distance. So accordingly, we have to implement, whether it is for robo or any other machines, we have to identify this. So a person who can walk will be having different response time, putting his hand will be having different response time. So all this calculation has to be, all this activity has to be taken care by installing the safety components. There is a separate device for measuring the stop time. So that device will just kind of a diagnostic device which take the feedbacks from all the safety components or important components from the machine, like encoders, all drives and everything, and it will give you the immediate result. Okay, this is your stop time required for stopping the machine after giving the stop command. So with this calculation, you can do another calculation and you can fix the light curtains or appropriate put the guards in such a way so that your operator will not able to meet any accidents during the operations. So we have seen this how to select the components and how to use it, and what is the stop time also have to be calculated. How to calculate everything. Maybe there is separate devices, but still I'm just saying these are the points which need to be covered, taken care during implementing the safety. Next is circuit evaluation. So any circuit or any machines will be having some three things. One is inputs, which will be in the part of the machines. Next is the logic controllers, which is the heart of the systems, means it will be in the control panel, and then outputs. The output might be the contactors, drives, anything, actuators, anything. So these three will form the one circuit. Okay. So what happens is people will use all safety components in the machines. That is the input devices. That will be a clear-cut things. After that, hello, could you hear me?
Yes.
Yeah. After that, people may not use the control panels. Okay, proper controllers in the systems. And if suppose they are using, they are not wired properly. This is one of the example here. Okay, this is the input device. Okay, and this input devices has been connected to the controller systems, and this controllers directly monitoring or directly controlling the output device motor. Okay, this is a regular safety PLC. Sorry, this is regular automation PLC. Okay, this can be used for only the communication, or you are taking the feedback to this particular devices. So you can be giving some feedbacks. Okay, this is the right way to use the input devices as well as control systems. But if you use in this way, like say they will be connecting the safety light curtains or safety components to the safety controllers, and these controller again given feedbacks to the regular automation PLC, and this PLC will control this main motor. So this is defeating the purpose, means you implementing this kind of components and devices, but still you are not achieving the safety level because of using the non-safety devices in the loop. So this is not the right way. So if you are using the safety input devices, definitely you have to use the safety controllers to monitor these devices. Okay, the safety controller is the heart of the systems. I will tell you why that is most important in the upcoming slides. After that, this has to be properly taken or control the main controllers, I mean main output devices. This is what need to be done. So by using this method, you will be spending money, but you will not able to install the, you are not doing the right way of implementing safety. As I said earlier, you can see the list of international standards, EN ISO standards, the left side, that equivalent to that Bureau of Indian Standards, which is created. Maybe very soon it will be coming to the regularizations. So we all need to follow certain standards very soon. It is not, but almost it is started very long back, and it's going to be coming to the execution. So you can see this risk assessment standards, what it is and what is the equivalent to that. This is the 13849-1 equal to that. If you see, this is the e-stop standards, and it is equivalent to that. So many such things are there. So we can see this safety performance level. So I have explained there is a one certain matrix which need to be carried out to identify what is the safety level required in your machines. It might be middle level of safety level, or it might be required a high level of safety, whatever it might be, but we have to see, we have to check each and every process. This is this safety level can be, first you have to go one by one safety circuits or one by one safety functions. It cannot be do for one performance level for entire machines. Okay, first you have to bifurcate, or you have to identify number of safety functions in your machines. Okay, and then it has to be carried out, means so you have to starting point of to gauge the risk reductions things. So from here you are going S1 and S2. S1 is severity of injury. S1 is a slight, which means reversible injury. If it's a small cut or something, over the period of time it can be cured. There is nothing big damage will be created on your any of the operators to the operators. And S2 is something irreversible, very serious. So if hands are being cut, or it can be also fatality and many things. So anything related to irreversible can be taken out into the S2. Okay. So you have to identify what will be the injury. If at all there is an injury happens, what is the level, what will be the very slight, or it would be a very serious one. Okay. Further to that, you have to find out the frequency. The frequency F1 is very seldom to quite often, or exposure to the exposure to time to the risk hazard is very short. Means you will be exposed to that particular hazard for very minimal time. Okay, then it could be F1. But if you are frequently exposing to the hazard, or you are exposing for long period, okay, then it can be classified as F2. And then P1 and P2. P1 is possibility of avoiding the hazard under specific conditions, and P2 is not at all possible to avoid the hazards. Okay. Now you can create a graph in your machine. For example, let's say you find there is a very minimum injury. I mean, reversible. It is a reversible injury, and then you find the operator is very less number of times he is going to expose to the hazards, and And there is also no possibility of, even if suppose he is exposed, there is no possibility of avoiding the hazard. So S1 and F1 and P2 will be, you will be ending in the performance level B. The risk level is not so high. If you think, okay, if suppose operator gets injury, there is for sure it cannot be reversed. He can lose his hand or fingers or something. Then you have to go to S2. Okay. The moment if you come to S2, you have to pitch in the place minimum of PLC, that is mid level of safety. And if maximum level is PLE, that is a maximum level of safety. So with this graph, you have to identify for each and every safety functions, each and every hazards, whether this particular hazards can able to have this kind of activity and this. So this you can calculate what will be the performance level for each functions. And cumulatively, the highest performance level required would be the you have to consider for the missions. So you can see if it will come to the E performance level is E means your mission is in a high risk. You have to implement the highest level of components to use and reduce this risk level. Any clarification, sir, till now?
So there is one question asked by Vipin Das, so I think we can answer it at the end of the session, sir.
Yeah, okay. So, and today I have taken one particular machines which is having more hazard and press machines. It is generally used in many industries at different requirement, and this concept can be we can see what are the hazards in that press machines, what can the possibility of accidents, and what are the components can be used to avoid these accidents. So I just don't want to explain much about press machine because many of the people have exposed, many of people are used for press machines, or they'll be having the press machine in their facilities. Okay, they know what are different type of mechanical presses, hydraulic presses, pneumatic presses, everything they'll be used. Okay. This is the safety standards which has to be carried out is EN 692 and 693, or you have to go for 13849-1 for the discusses and SRPCS. So there are some of the examples how accidents can be happen. So if operator during the loading of this particular component in the press, so there can be chances it can be crushed or punched. There is a places where press machine is quite bigger, where one person is operating from other end, another person is operating from this side. There is a miscommunication which can lead to the accident. Means he is working on this machine, but at the time the operator, due to non-visibility or some other miscommunication, it is sorry, he is started the cycle and this operator get into the accident. Second thing is you can see this they're using this 2-1 control station very near to this machine. There is not proper distance calculation has been calculated, and without this operator is started the machine and both the people get met into the accidents. This is by pictorial we can say that he is working under the machine and someone started the machines. It can create to fatality. So whenever you prepare a guard, okay, and for the press, okay, so you based on the operator's body or head or leg, whatever it may be, he is interacting to the machines. There should be a minimum distance of this guard has to be calculated. So this is something which need to be carried out when you are putting the some guard for the press machines. So this is a, I don't want to show that, but when you see this can applies to the press machine. Two moving parts moves towards each other, or one moving parts moving towards a fixed part. What are the safety components can be used in the press safety? These are some of the components. See safety like curtain in the front area where other sides everything have been covered with mechanical guards. Okay. This is the 2-1 control stations which is used in this whenever operator loading the component, and then he can press and he can start the cycle so that both the hands are engaged outside the machine. If suppose this mat can be put it in this surface, whenever he is standing on this mat and loading the component, machine cannot operate. Or else you can use this foot switch for operating the press area. I will explain why this particular foot switch is there. And obviously emergency stop will be there in the entire machines. If this press machine is engaged with robo or some other activity, and you have to cover the robo area, and then the robo area coverage perimeter guarding has to be used by the door handling system, means and interlocking devices, and this has to be with what do you say, integrated with the control systems. And all these are the input components, and safety relay is the controlling devices, safety controllers, which would be considered as the heart of the systems. We will see one by one what are these components, how it can be, what is the features or something. Safety light curtain. I'll just going through the safety light curtains. So safety light curtain is a device which can be used in front of the machine to protect or to indicate that operator that there is a crushing area. If you insert, the machine will go to the stopping mode. So it can be identified like finger protection, hand protections, and body protections. Even if you insert a finger, then also it should be identified immediately. If you insert a hand, maybe it may not identify the finger, but it will identify the hand point. And if you trying to walk in that area, so it can be a body protections. So this device would be in a single extruder device so that it will not have any, even any physical damage happens, this device will not get broken or something. So this light curtain is having maybe many of the people are using till now. There is no doubt in that. So many might be using safety light curtains. Many are using non-safety light curtains, but we have to go through the standard. If you want to comply the standards and you want to have the complete safety in your machines, then definitely you have to implement the you have to use the safety certified light curtains. And what is the additional features which we have it right now, if you see, is interacting this light curtain with your smartphones using the Bluetooth technology. This safety light curtains is having the Bluetooth chip. Okay. And with this, there is an app called AOPD Diagnostics, which can be installed in your smartphones. Okay. So the moment you switch on this app and this light curtain gets connected each other through Bluetooth communications. Okay. The moment you connected, you will be finding out the light curtain model number in this, which is similar to the connecting Wi-Fi or connecting the Bluetooth phone to your car. Okay. You will able to find out what are the devices available in this nearby area. If suppose you are using many devices and it list out all the names, if you are using very limited device, it will limited only things. Suppose if you are using many things, you will be having model number. Let's say press machine 1. So this light curtain will be, you can rename it into press machine 1. So next time it will be showing as press machine 1. Okay, you can directly fetch the information from this press machine 1. The moment you connected to this safety light curtain in your phone, you can see what is the model number, what is the serial number, what is the resolution, whether it is a finger protection, hand protections, what is the height of the light curtains, number of beams in the light curtains, and the software versions, everything will be visible in this device. And what are the features has been selected for using these devices, like blanking, all other many features are there. These all can be identified in this. And you can individually see all the beams status. You can see whatever you are seeing in the black cover, you can see it in the phone, because here it's not visible, but you can see each and every beam, what is the status. So what is the operating mode? If it is automatic, or what is the status? Field status free means nothing is interrupted this like curtain. So it is showing us free. The alignment between the emitter and receiver, it is exactly matching. So the beam level is, signal level is 3 stars are there. And what is the output status? OSD is nothing but output, which is in on. Number of times this devices has been cut off 230 times. That is a OSD cycle counter. What is the supply voltage? 24 voltage. And then what is the operating time? Means number of from the beginning, number of hours this light curtain have been switched on, kept in switched on. That is 53 hours. The light curtain is in power on conditions. So this information will help you to do the diagnostics very easily. And with this, you can try to reduce the downtime of the machines, especially for alignment. If suppose any interruptions happened in this light curtain, then it can also show you which of the beams it has been interrupted. So you can see from 37 to 43 beam has been interrupted. So the field status from free, it is changed to interrupt. Beam signal level is no stars because it is interrupted. Output status from the on, output was on at that time, now it's off. And the cycle counter has been changing, but this is a different picture, and the voltage also will be different. So this will be something common, voltage and hour time. I'm just playing a small video. You can see whatever I've explained will be there in the video. There will be no audio for this. So the moment you are trying to align, you can see each and every beam. So beam signal level is also all 3 stars are there. So alignment is perfect and you can start the machines. If any clarifications required for this device, you can fetch out the manual directly over from this app if your internet is on. And you can also make a report of this particular light curtain, and this could be treated as your MOM or something. So this is one recent advancement which Smushla have done this. Next is 2-1 control stations. 2-1 control station is something in a press machines. Operator has to load the component on the press area, pressing area, and then he has to take a hand out of it, both the hands, and he has to engage both the hands in this particular area. Okay. And he has to press simultaneously. It cannot be like pressing one button at a time, and after some time it cannot be allowed. So this is something device. This is actually a mechanical device. You can see there is nothing. There will be inserting 2 push button stations, and this 2 push button distance between 2 push buttons should be minimum of 260 mm, and the time should be within the both the push buttons has to be pressed. Maximum time allowed will be 500 milliseconds. And this has to be mounted by a safety relay. Separate relay for this particular device has to be there. So this will have the inbuilt timer which will measure this time taken between this button activating and this button activating. If there is a delay, means it is, let's say, 600 milliseconds something, this relay will not give output to start the machines. So this is most important device when you are using the press machine in your area. So you can see what is the standards used for this press machine 2-1 control, that is EN 574. And with this relay, you can also achieve the maximum level of safety. And then foot switch. Foot switch is a normal switch. Generally, we all will be using operating the machine through leg. Okay. But what happens is sometimes the operator will put some weight on that foot switch and try to bypass this machine. Means it will be kept in on always. So he is trying to do the production very quickly. So this will create an accident. So to avoid this, there are certain foot switch where it has, if suppose it is continuously pressed condition, it will go to off mode. So generally it is in off mode. When you press, it becomes on. When it is continuously pressed, okay, it goes to off mode. And then again, you have to reset using this blue color push button, and then you have to restart the machine. So this is a one foot switch can be used where operator is trying to bypass the particular options by putting some weight on the foot pedal. And also you can see this cover has been designed in such a way because operator cannot put some external object through sideways. Okay, and in general, safety shoes will be used in operators, so it has to having an adequate space to insert the safety shoes. If there are some foot switches which will be covered flatly, so they cannot install this foot directly. They have to insert from the side or something. So this is not a proper design. So this is the safety foot switch proper design, and the safety options are also available in this foot switch. Emergency stop. So any electromechanical components in a safety concepts, okay, should have this symbol arrow mark with circle. This is called positive brake NC contact. So let's say emergency stop or limit switches, foot switches, any electromechanical components will be having the contact element which will be moving when you are actuating. The contact element will change over its position from closed contact to open contact or open contact to closed contact. This is a regular practice for any electromechanical component. So even if emergency stop is also same. When you press this emergency stop head, the contact element, which will be usually NC element, closed contact, will change over its position from closed to open contact. Okay, so this is a regular option, but in terms with respect to safety, you should ensure the component at whatever the time. Okay, you are not going to use emergency stop every day, every shift or something. You may use this emergency stop after 20 days or 25 days, but whenever you press this emergency stop, it should function. Means the contact element, the closed contact element should become open element so that all this machine has come to halt position. Okay, there should not be any chances of contact damage or something. Because of that, this opening of the contacts is not happening. In general, they'll be using a spring inside this device, and this will be such a way the spring will be in a compressed state. When you press it, the spring will be elongated, and so that the component's closed component will becomes open contact. But due to the arcing or any other situation, the contact is jammed. The spring which is used inside this component will not have enough force to open the closed contact to open contact. Means from NC it cannot become NO because the spring will not have enough force to open it. Okay, so this is a failure of the component, and this failure leads to a dangerous situation. So the safety components doesn't mean that it will not fail at all. Even it fails, it should fail in a safe condition. What is the difference between conventional is, instead of spring, the NC contact will be directly connected to this actuating devices. When you press this actuator emergency stop head, okay, the contact element, even if the contact is blocked or this element is blocked or jammed by pressing mechanically, at least it will break and become open from NO to NC. It becomes from NC to NO, not NO to NC. It's from NC to NO. It becomes happening. So even it fails in a safe condition. So that is denominated by the arrow mark with circle. So any electromechanical component, if used for safety requirement, should have this particular symbol. It might be limit switch, it might be door interlocking systems, it might be interlocking door switch or door interlocking guard systems, or pull guard switch, foot switch, whatever it might be. If it is electromechanical comp, this symbol should be there. If it is not there, it is not a safety component. It is a simple device. Suppose you are claiming that you are using that red color push button as an emergency stop, and but internally, if you see the contact element doesn't have this particular symbol, means they are not comply for safety. It is a regular push button only. It cannot be used for the safety requirement. And this particular emergency stop should be used surrounding to the machines both inside and outside if it is machine is so bigger. So wherever operator is going to work inside the machine or outside the machine, and there is any chances of no visibility to the one operator to other operator, so this emergency stop should be there, because if he exposed to any of the hazards, he can use this emergency stop and stop the machine immediately. Safety relay. Till now, we have seen some of the input components like curtain, emergency stop, foot switch, mat, many things. So as I said, the safety relay is the controller, which is the heart of the safety systems. And all these input devices has to be connected to the safety relay. And from this, it has to give the command to the output devices to stop the machine. Okay. Why should we use a safety relay rather than using the regular automation PLCs? So there are some points. So it will monitor the safety components which are connected to this device safety relay. If there is any open circuit, it can be identified. If any short circuit, short to the ground, if any welded contacts, okay, failure of safety controller positive welded contacts, if it is any fault in the system, entire system, if insufficient operating voltage, this safety relay will identify and it will stop the machine before any accident happens. So this is the quite intelligent device compared to the many of the safety input devices, and it has to be wired or it has to be used appropriately so that the feature of this, the safety level can be achieved with this safety relay. Relay will be having three important things, which has, because of this we are using this device in every safety circuit. One is redundancy. So you can see here there will be two microcontroller unit. One, because if any one thing fails, the other one tells to you or tell to us that I am not able to get the feedback from other controller, means that is something happened to that particular other controller. So this will not allow to start the machine or function the machines. It will immediately stop the machines. So by default, it will be having the two controller inside, and it will also have the provision of monitoring the two contacts of the same device. Suppose you are going to monitor the emergency stop through this safety relay. Emergency stop should have two NC contacts. The two NC contacts should be wired to this particular safety relay. One NC contacts to one channel, another NC contacts to another channel. And this will be let's say this will going to monitor this, and this will going to monitor this, and these two will be interconnecting or exchange the information. If any of one controller not able to give the proper feedback, means something happened to the particular channel or something, so it will stop the machine. Next is reset. So reset means if suppose you are pressing the e-stop, machine stopped, and you are releasing the e-stop, the machine will not start immediately. You have to reset. First, you have to check by pressing the reset. It is checking the 1 second, the control system, everything is fine. And then it will allow us to restart the machine. Reset is different, restart is different. Okay. And also this is the output contacts. So you can see there is a 2 contactors have been connected to this output contacts, and the healthiness of this contactor also can be monitored along with the reset. The auxiliary contact can be connected to this reset push buttons. When you pressing the reset, so it's not only check the input devices as well as internal circuit, it also checks the external devices, that is like called contactors, relays or something. So all this can be monitored through this safety relay. So all will be connected in the dual channel, means redundancy purpose. Okay. If anything one fails, the other things will let us know this is something failed. And most important thing, this will do the periodic self-checking internally as well as externally. This relay will keep on sending certain pulses to the devices which is connected to this safety relay and check his healthiness, whether these devices are functioning properly. So this self-checking is a concept which is also one of the main important point of the safety relay. And you can see this is the positive gated context. In general, you will be using many of the relays, safety, not a safety relays. I'm saying about conventional electromechanical relays. So these relays are the like some of the MY2N relays of home run, or all these relays are electromechanical relays, and these relays are not safety relays. Means if you energize the coil by giving some voltage, it will change its position. The contacts will change its position from its original position, and because of this, you will be getting some output changeover. But there is a certain option, certain things due to contact jamming or welded. This, if NC is becoming NO and NO is becoming NC, this is okay. But what happens? The NC contact is welded. The NC will remain its original position. The other side of the mirror contact, that other contacts will change its position. Means that is a malfunctioning. It is giving a wrong feedback to the control systems. So this is not possible because of the positive guided contacts. All these outputs are interlinked. So whatever its position, original position, that can be, if this changes and this all change. If this is not changing, this also will not change. Means this is not going to give any wrong information to the control systems. So all these three will help us to achieve the SRPCS. This is safety related protocol control systems can be, the intrinsic safety can be achieved. So this is some of the press mission of manual operating machines. So we have seen certain accidents earlier, how it can be possible. So this can be avoided by putting light curtains and mechanical guards, so that even this operator is trying to operate, and this person is trying to do some activity. It has been protected with light curtain. If he insert his finger or hand, the machine will stop, even if he tries to start the machines. So you can see in the top view where this is fully covered with light curtains, and there is a mechanical guard from here and here, and there is an emergency stop here, all the four sides, and he is using the 2 control stations here. So each operator has been protected by using the external devices. If robo machines are integrated with the press machine, then in such a way it has to be guarded, perimeter guarding has to be there. Mechanical fences has to be installed, and this has to be monitored with proper interlocking device at the door area, and the emergency stop should be used inside as well as outside, or mean this side where operator will be here, other side also should be covered. If it is a complete press line, bigger press lines, then you have to use certain interlocking devices. Means it will be having a certain options that if suppose operator open the door and go inside, and he is doing some activity, and mistakenly the other operator closes the door and start from the cycle, the operator who is trapped inside the machine can use the particular panic handle which will be available in this device, and he can simply open the door and come out and stop. The machine will be stopped. So such kind of high-end sensors, interlocking devices also available in the market to use along with this particular safety doors, interlocking things. We will see what are the interlocking devices for. Here it is. So you can see this red color handle is a panic handle, and this is the handle which is used for locking the door. Suppose this will be the actually this will be the inner part of the machine. This will be the outer part of the machine. Operator is trying to get inside the machine area. He has to get 24-volt signal from HMI or any authorized signal to this device. Then you are allowed to open the door. With using this handle, you can open the door, get inside. Okay. Once you went inside and doing some activity, the other operator finds no one is there in this inside the machine area. He just simply close the door and try to restart the machine. and the person who is operator who is trapped inside, he can use this red color handle simply without any electrical signals or something. Just mechanically he can open the door and he can come out. There will be no restriction to use this handle to open it. Okay, either electrically, mechanically, no restrictions will be there. No inputs are required. But at the same time, operator cannot go inside and he cannot close the door by using this handle. This handle can be used only for unlocking, not for the locking. And suppose there is also another options available in this. This will be a lotto provisions will be there. Operator want to go inside, he can just open the door. There will be a lock provisions will be available in this area. He can put the simple padlock and take the key inside. So till the moment he come out and open the lock, he cannot use this handle to lock the interlocking device and start the machines. So this is another solenoid interlock with locking features. Next is double reset acknowledgements. Generally, as I said, the bigger machines are bigger processing areas. If operator goes inside and he is doing another side of the machine and people doesn't know, he will start. Suppose this operator goes inside this area and he works somewhere inside this area, want to do some maintenance. But other operator doesn't know that someone is inside. He'll try to press a reset here and try to start the machine. But if you use this double reset, it will not allow you to start the machine. So means the operator who went inside or a person who went inside has to come, press one push button, reset push button, which is placed inside this Likert area near to this robo area, or press it and come out within a time frame and press another reset button here. So 2 times the reset button has to be pressed. Then only this relay will allow the machine to restart. If suppose someone doesn't know and he trying to press this reset button alone, the machine starts, then you will come to know, okay, somebody is already inside. So that is the reason this reset is not allowing. So you will come to know, okay, we have to press inside, then only come. So he will wait for the operator or he will try to contact the person who is inside to check whether he is available there so that he can wait till the person is coming out. So this is also one of the concept which is not used in the machineries very regularly, but this is a useful concept for having the bigger machineries or bigger area where the visibility issues are there, because the person who works on other sides, there will be no, we are not able to see that person who is working inside. Next is the key trap systems. Till now, what we have seen is of more of electrical interlocking systems, but there is something called mechanical, pure mechanical. This is the component which is used in the doors of the any machines. It might be guards or fences or anything. And this is the key which is in the control panel outside the machine area. So if his operator wants to go inside and you want to open the door, he has to use this key. If you want to take out of this key, it has to be connected with the key setter switch. You have to turn and take out of the key, like by key. You have to, if you want to take out a key, you have to switch off and take it. Similar way, when you turn, the contact element here will change its position and it will stop the machine. Okay, and then you can take the key. That means while you entering into the machine, the power system of the machine has been cut off, and then you use this key. And you insert this key here and then you can open the door. Till the time you cannot open the door, it will be locked with this device. There is another options where you have to insert the key, open the door. While going inside, you have to take the other key which is already present in this, so that if you come out, put this key back here and then close the door, then only you can take this key and you put it back into the key setter switch and restart the machine. If you are not putting this key backside, you cannot close the door and you cannot take this key out as well. So this is like a what to say, lotto kind of arrangements, such a way. So this part is purely mechanical. There is no any electrical involved here. This is electrical is involved only here. If multiple people wants to get into the machine, then you can use three. There is an option of 3 keys. Okay, for if there is only 3 doors and maximum 3 doors, and you can use this. And even this device, taking the key out of this device is also not so easy like this key setter switch. You have to give some 24-volt signal to this device, then only you can able to fetch the key out. And if you want many people, that is like 6 people or 11 people to get into the machines, and each one of them should carry the keys, then it can be multiplied like this. So if this is the master key, this master key put into this area, then only all these keys can be taken out. And then only after all the keys coming back to this particular area, then only this master key can be taken out and put it in this control systems. So this is called key trap systems. Next is the safety fence. This is a perimeter guarding. This is the fence which is installed surrounding to the machine area, not on the machine area. Okay. So wherever the perimeter guarding is required, we can use this safety fence. Okay. This safety fence is follows the mechanical standards EN ISO 14120 as well as safety sense of 13857. So what does this standards tells for this safety fences? This safety fence should be designed in such a way it cannot be used as a ladder or steps to climb over. So the design is such a way no one can able to climb with the help of using this particular fence. And it also has to be the fastness, whatever used for along with the safety fence, it has to be designed in such a way that during the maintenance or installation, the fasteners should not be misplaced or it should not come out of the fence, so that while installing they use all the fasteners and put it inside properly. If it is missed out something, what happens is the operator will not properly assemble this safety fence. They will just instead of 3 nut and bolt, they use only 1 or 2 nut and bolts, which over the period of time it will be weakened on the safety fence. And this safety fence is also tested, okay, as per the impact test criteria. Okay, you can see there is 100 kg of force which is traveled at the speed of 20 km/h speed and had an impact above the half of the area of the safety fence. Okay, sorry, exactly. If you see, you can see that the safety fence from the ground level, it is because if you had an impact and the bottom, because the safety fence is grounded well, so the impact will be less. So it should be above the half of the level. The total height is 2 meters. The impact area is from the ground level is 1420. So exactly it is 1420. So if with this 100 kg of weight traveling at 20 km/h speed and having the impact above the half of the area half of the height of the from the ground level, still this fence will protect the operator who's standing outside. This fence is not detaching out from the ground. It will be used to be a protector. So from the weight which is traveling from inside, means if suppose the robo is something while assembly or taking something, if it's ejecting the component, the fence will be a protector. So it will not have any damage. Means if this fence is uprooted, then it can also give the problem to the people who are standing around the machines. So it is observing that impact. So it is not uprooting from the ground. So this is the most important criteria when we have a design of as per the standards. And safety distance, this standards also says different level of safety fences to be height. I'm saying about height has to be used as per requirement. But in general, we are providing 2 meter height, which will be a common things for most of the requirement. So you can see what is the formula to choose this. So there is certain formulas will be there. With this formula, we are able to select this height. So if the height of the dangerous area is, you can see with related to this picture. So from the ground level, the machine surface level, the height of this dangerous area is more than the height of the, if you, this is let's say 1000 or something. Yeah. And the distance of B, that is a height should be there. So it will be like 800 mm, 1600 is there, then it would be of 800 mm gap should be there. If it is less distance, then you can keep on decrease it. So, but in general, we are providing the safety fence of 2000 mm, that is 2 meter height from the ground level. As per the standards, the visibility of the machine should also be very clear. It cannot be shabby or something, so that the person who's standing outside and watching the machine should not able to have any visibility issues, because he has to know what process is going on inside. So the post color and the mesh color has been designed in such a way, or colored has to be selected in such a way, the visibility will not have any impact. Next is the scanner. So scanner is the device where if you want to cover huge area, a bigger area, and different profile has to be there, then this scanner can be used. Okay. So if light curtain means whenever the area is very small and within that area, within the distance a person enters his hands, put his hands, it will be detected and it will be giving you output. But if you want to area wise in the ground level, let's say you from the area where you install the scanner, within a range of 5 meter or 6 meter, you want to have some outputs that can be possible with help of this scanner. And the coverage is also will be wide. So you can see this is the scanner position and coverage is 270-degree coverage, and distance is also up to 5 meter. It can give the output, and after that it will be a warning zone. If suppose operator or somebody, you are selecting up to 20 meter, a person is entering into this area, it will give a warning alarm or something to you, telling that there is operations going on, you have to step back or something. But still operator is coming forward and it is touching the area of 5 meter from the hazardous point, then immediately it will stop the machine so that it will not have any accident or something. So this is the one of the scanners should be used where if you have any larger area to be covered. If it is smaller area, then you can use a safety mat, which is a simple mat kind of arrangement, but it's not simple. It can be put in the floor. If somebody stands on that mat, it will give the output. So this is our complete solutions with respect to not only product selling, but also complete concept with respect to consulting and engineering, integrations and implementations, everything we can able to provide. And the systems consultants also we have it. So with this, I'm finishing my session. I know this is a very big topic, but I will try to cover most of the important aspects, but so that I've touched my basics. But it is very big topic. If you have any clarification on something, you can write to this number or you can contact me through this number. Thanks for your time and thanks for your patience as well. Let me go through the chat box for any questionnaires. How can a PL can be rated to PFD? You mean to say performance level related to the PFD means, sir? What is your meaning to PFD? PLD or PFD?
It's probability of failure on demand, PFD.
That is.
So that is basically if, so for example, if a light curtain or an emergency stop, so if for a machine to have a PL level, means PL level, PLA, PLB, C, D, or E. So how will it be related to that probability of failure on demand of that particular guarding system? How can we assess that?
Sir, performance level is actually for that particular safety functions requirement. That PFD is for the particular safety device. Okay, it cannot be with this, maybe by using the safety devices. Okay, each safety devices have its own MTDFT value, or what you are saying, PFD, everything will be defined by the manufacturer for that particular devices. If that device is low coding or low level of safety, and performance level is requirement is very high, then we cannot relate it. You cannot use to that particular requirement. For example, if the safety level is performance level E, high means you need highest level of safety level. For that, if you are using the lowest level of safety devices, definitely you will not able to achieve. To achieve that level, again you have to follow certain procedure. Means you have to use the two switches simultaneously, and you have to have the controller and two output devices. Both has to be monitored at the same time, separately as well, and as well as it has to be interconnected. So all these things, design structure has to be there. Definitely PFD will have a play role, but PFD alone will not have any role to define the performance level. Hope it is clear, sir.
Yeah, it's clear. Only thing is the time of failure. For example, if I do need to have a machine with a performance level, machine guarding with a performance level of PLA, what basic PFD would I need to have a risk reduction factor of 1 in 100 or 1 in 10? That is also a factor, right?
Yeah, that is also a factor, but that factor alone will not define the performance level. That's what I'm saying. Along with that, you have other factors as well. What is the diagnostic coverage? Means of the system. I'm saying about not the product. I'm saying diagnostic coverage of the systems. What is the this MTWF value? So what is your other checkpoints related to the safety functions? Everything has to put into that role. If the, as you said, if your performance failure demand is very means it is comparatively very high, then there will be a your level also will be reduced. That's what I'm saying.
Yeah, thank you.
Yeah.
Yeah, thank you. So thank you, Prakash. It was a very wonderful and very informative session. And you have covered various standards governing the mission safety, and you have covered the how we can minimize the risk using the 3-step method: direct, indirect, and providing the signages.
Yeah.
And you have covered on the various guarding, that is separating guarding and non-separating guarding, and stop time measurement. So what are the things we should consider for installing a safety scanner, the response times and the safety distance, and what are the safety circuit evaluation and the correct method of connecting the safety circuits and the input devices. So, and the safety level performance. So based on the severity, frequency, and possibility, and various safety devices which can be provided for a press for safe operations, and different type of safety devices, and safety components with the fail-safe symbol, and the safety relay, and last you have covered about the safety fencing and what should be the height, strength, and formula for choosing the safety fencing and the visibility level. So thank you. It was a very good session, and I request Mrs. Meenu Vijayan, Joint Convener of HSE Forum, to deliver the vote of thanks.
So before concluding, I have a few questions here, and also in
Yes,
chat
sir.
box, people have given asked some questions. So my question is, sir, you talked about this type A, type B, and type C harmonized standards.
Yes,
Can
sir.
you just explain what exactly it is, and how we classify it as type A, type B, and type C?
Okay, you want to put back to that same 3 slides.
Yeah, just want to know what exactly how that classification is being done.
one, right, sir?
No, the other one, sir. One more. Next slide.
This one.
Yeah.
No, this is actually example of those standards A, B, and C and all. Okay.
Yeah.
But I'll come back to the original thing. This one.
Okay.
So if you want to implement the safety, okay, in your existing missions, or let's say you are getting a new missions, that mission is called press mission. Okay. You want to put a new press mission, or you want to put on robotic integrating missions or something. Then
Okay.
for that, you have to have some reference documents to implement the safety. Okay. So directly, if this you want to go directly, you can go to the C standard of this particular mission type. I'm saying mission means mission type. It might be different missions. So directly you can refer that particular standard straight away. You need not to go to this A and B and A and B. Okay. So the standards have been put in such a way. Okay, one is of generic way. It will be covering all the details in generic way. Okay, it will not tell about with respect to mission wise. It will be tell about the safety function wise. Okay, and C is something which will tell what are the important factors which to be carried out when you are doing implementation with respect to certain machine types straight away. Okay. So this is the difference between A and B, A and C. And B is something where the components which are used to implement the safety, okay, whether that is as per the standard or not, and which standard we have to refer, it will talk in the B2. And the safety concepts which has to be carried out will be talk in the B1 aspects.
Okay.
Suppose if you want to do some implementation on existing mission, which is a packaging missions, directly you can go to the packaging mission standard, okay, EN415, and this packaging mission standard will tell you, okay, these are the things you have to carry out, and this standards will also take some reference of A and B as well. Okay, it need not to be exactly this one will be there, but it will take some references from A and B as well. It will also tell that, okay, in A it is mentioned like this, so you have to carry it like this. Also in the B means if you are using ESTOP as per B standards, the ESTOP has to comply EN ISO 13850. Likewise will be there. But other aspects will, other than this packaging mission, it will not talk about. That's what I'm saying. So if specifically, if you want to have certain standards with respect to mission, you can directly refer to that particular standards. If you are building some special purpose missions, it will not be classified into any of these categories, C category missions. Then there is no options. You have to use both A and B only.
Okay. Yeah, it's clear, sir.
Yeah.
Thank you.
There's another question by Abdul Aziz. What does CAT 4 denotes?
CAT 4, category 4. So earlier, before this 13849-1 comes, there was a certain standards, means they were talking about the category level. Before performance level discussions, earlier it was used the category level. So like category B, 1, 2, 3, 4. Okay. So during the recent upgradation of all the electronic, all these things, it has been revoluted and becomes like performance level 1, 2, 3, A, B, C, D, E. So category 4 is nothing but performance level equal to the performance level E. That is also maximum level of safety category.
Yeah, thank you, Prakash. So request Meenu Vijayan, Joint Convener of HSE Forum, to deliver the vote of.
Thank you, sir. A very good evening to all. First of all, respected convener of HSE Forum Kerala, Sri Nayan Nandakumar, is the Senior Associate Vice President of Carbrandam Universal Limited and Honorary Secretary of National Safety Council Kerala Chapter, Sri Ramesh PM, for giving the opportunity to conduct the 19th HSE Forum monthly evening talk in an esteemed manner. Also, I would like to thank Sri Gogul V. Babu, Manager Safety of HLL Life Care Limited, and Sri Binoj Nair, Manager Safety of Thermo Penpol, who are the committee members of HSE Forum Kerala, who delivered the welcome address and the facilitation of the whole meeting. And also, I would like to thank on behalf of HSE Forum Committee, our speaker, Sri Prakash K, Zonal Manager, Smersal India Private Limited, for giving a knowledgeable talk on the modern trends in machine guarding and safety sensors and the various standards which we want to refer for this. And also, I'm sure that this session was really informative. Thank you, Sri Prakash K, for sharing your valuable time and information with the HSE Forum members. Last but not least, a big thank you to each and every one of you for your wonderful participation and support. Okay, thank you, sir, for doing that talk.
Yeah, I once again thank you to each and every member of this forum to creating this awareness program, because which is very much required in current industry situations. So this awareness will have better information spreading towards down the line peoples, and this will help us to have the safe environment in each and every industries which we are working for. So I hope this information or this presentation will be definitely little bit of informative, and this can be improvised at any point of time based on your feedbacks and based on your requirements, because as I said, I've just touched up the basics. I've not covered anything much detail. Thank you, sir.
Thank you, sir. It was very informative session. Thank you, sir.
Yeah.
So shall we conclude our meeting?
Yeah.
Okay.
Thank you.
Okay. Then we will leave.